Hello, my name is Lucas Stafford, and this is a short video in which I will explain the design and success of the 2014 to 2015 Baylor BUV. BUV stands for Basic Utility Vehicle and is a rugged transportation solution purposed for rough terrain in rural areas. Baylor BUV is a humanitarian outreach organization with the mission to use our engineering expertise to provide the best possible product for those in need. The major design requirement for the May 2015 National BUV competition was the ability to carry 150 gallons of water through a punishing environment. This video is a walk around the BUV to showcase the highlights of the design. The roll bar was an incredibly important safety feature that took a lot of welding expertise to create. The half-inch walls of the pipe had to be cut down and welded properly to ensure strength. These are the 55-gallon barrels that held all of the water. All three are interconnected with valves on each end. One valve is open for filling the barrels with an external pump, while the other is closed, and vice versa, for emptying the barrels. Next is a preview of the BUV's powertrain, for which I personally was responsible for the design and fabrication. The powertrain was built as a separate module so that it could be removed and worked on separately from the car. This was an innovation in the design for which the host of the competition gave us a significant amount of points and praise. It also was much easier to fabricate as a separate module because it can be extremely difficult to weld components together in small spaces. Another major design requirement was that the BUV had to have no greater than a 10 horsepower engine. Our 10 horsepower Briggs & Stratton is connected to a Comet 500 series CVT with a gear ratio range of 3.34 to 1 at low rotation and 0.81 to 1 at high rotation. The driven unit of the CVT is connected to what we call the gear reduction shaft. At the other end of the shaft is a 14-tooth sprocket that is mated with a 56-tooth drag specialist motorcycle sprocket, resulting in a 4-to-1 gear ratio. The motorcycle sprocket is then connected to a transmission pulled out of an old Geo tracker. The BUV was designed to run in second gear, which has a gear reduction of 1.95, but at the competition, first gear with a ratio of 3.65 was exclusively used because in some parts of the track the mud was 2 feet deep. The reason we used the tracker transmission is because of the flexibility in gear choice and the reverse gear. Last in the powertrain is the differential. This Ponzi-Track rear axle was pulled off of a Ford Ranger and has a gear ratio of 3.73. By the time the power got to the wheels, it went through an overall reduction of 97.17 in second gear and 181.9 in first gear. This torque was crucial during the competition as Baylor's BUV was the only entry out of 15 competitors that did not get stuck the entire day. After the competition, we even used our BUV to rescue an 8,000-pound Ford F-450 that was stuck in the mud. Out of those 15 competitors, Baylor's BUV was one of 2 that had no failures during the competition. However, there are several issues with the car that need to be addressed before next year's competition. Not being able to shift the BUV when in motion was a major hindrance to our average velocity. Once we solve this problem, we will have access to our massive amount of torque when we need it and have the ability to reach speeds up to 30 miles per hour on the straightaways. Next is the rake angle. Due to inexperience, we mistakenly designed our rake angle to be about 30 degrees. This was a mistake because it made steering almost impossible. Every time you would go to steer the car, you actually would end up lifting the car several inches. This is not useful for a community to use for everyday heavy lifting. Baylor BUV is also attempting to utilize the tools at our disposal to ultimately create the best design possible. What we are doing this year to further that goal is including strain gauges on crucial members of the frame in order to accurately measure the loads and forces being applied while in operation. This will allow future members of the club to have accurate data to design against for a more efficient and reliable vehicle.
Kind of go over